All of you have signed the sheet. You have signed your attendance. Not yet. इनका नहीं हुआ. Thank you. Anish, you're there for science class or no? You're there? Last time you were saying you're not there. Shall we start? Have you done the homework assignment? Done? It was easy, isn't it? No? You still have to do objective type, or was it the numericals? You do the numericals, that is going to be helpful for you. What about the points? Have you done or no? No, none of you have done. What about you? Done now. Why are you defaulting on the very first day? Arush, what about you?
My practice of the numericals, but I didn't get the problem.
You are not there for the first class. Anish, what about you? First day only it got class. Very good. It has got reads now on the very first day, right? Which book got class? Please find out, maybe you have left here. No? So you have, at least you should take some other book and do it now. No. Do it, huh? All those of you who have not done, please. I don't like this. I've especially taken about 10-15 minutes on the very first class to explain to you the importance of time management. If you default it like this, it's going to be very difficult. Toshita, what about you?
Ma'am, read the objectives for the numericals.
Are you scared of the numericals? That's why you're not doing it? No, I think it's quite easy. Once you understand the formula, there's nothing but it is. And I've given you hints as to how to do the numericals. So you do it. You'll find it easy. Where did we finish? Refraction of light, we have done everything. Mirror formula, magnification, and the sums we have completed. Okay, so we have to do the second part of the lesson. And that will be regarding the refraction. Okay, if you look at this chapter on light, we have reflection and we also have refraction. Okay, reflection is brought about by mirrors, whereas refraction we are going to be talking in terms of lens. Now, even before we use this word refraction, let's try to understand what it is. Most of you must have seen, if you take a glass of water, for example, if you're taking a glass of water, and let's say you have taken water or something of that sort, and if you are dipping a spoon inside, does it look like this? Yes? Or if you put a pencil or a stick or your scale or something of that sort, you find that it appears to be broken here, but is it actually broken? No, we know that it is not. But it is appearing that something has happened. Why does it happen? It is due to refraction. It is basically due to refraction, a phenomena called refraction. So for us to understand what is happening in refraction, when you are having a glass of water and you are dipping a stick or a spoon or something of that sort, what is happening? How are you able to see the glass of water? Because light is coming from the object into our eyes. Okay. So when the light is coming, can you imagine that there are two medium? One is water and the other one is air. Okay. So the light is coming through water and then it is coming into air, and that is how it is entering into our eyes. Okay. So there is a refraction which is taking place when light enters from one optical medium into another optical medium. I'm using the word optical. Okay. Now, did you understand that there were two medium? What are the two medium? Here we have taken water, and obviously outside there is air. So when light is coming from, let us say, water, when light is coming from water and it is moving into air, it will not go in a straight line, but there is a bending which is actually taking place. Okay, so this phenomena is called as refraction. So what is refraction? Refraction is nothing but a change in the path of light when light passes from one optical medium into another optical medium. Okay. Now let's understand what is this optical medium. Can light pass through this? If I take a candle, can you see light here? Okay. So what type of an object is that? You know the word opaque. Suppose you have a tinted part exactly, or ground glass like this. What type of a glass is that?
Translucent.
Yes. Okay. It's a translucent. Here it is a glass. So when we are talking about water and air, obviously it means that it has to be a transparent material. Okay, can you think of anything else which is transparent, like air, water, what else?
Glass.
Right?
Glass.
Glass. Glass is made up of, okay, fine, very good. Glass is there. What else? What about transparent plastic? Yes, okay. So it can also pass through, okay. So when it is passing through different media, basically what is happening is the speed of light is changing. Okay. What is the speed of light in air? Anybody knows? Speed of light in air. How much is it? 3. 3 into 10 raised to the power of 8 meters per second. Okay. So what does it tell us? That in 1 second, it is so fast that it is covering a distance of 3 to 10 raised to the power of 8 meters. Did you understand that? Okay. So that is basically the speed of light in either air or approximately the same in vacuum. Am I talking about vacuum? I'm talking about the surface of the earth and the sun, which is obviously millions of miles away, millions and millions of kilometers away. So for the sunlight from here to come over to the earth, earth is having an atmosphere here, correct? But all this is what? Space, and it is vacuum. There is no atmosphere. Okay? But the speed of light in vacuum will be approximately the same as the speed of light in atmosphere, which is going to be taken something like this, 3 to 10 raised to the power of 8. But once it enters into the atmosphere, we will find another phenomenon, because the composition of atmosphere is not the same. We will talk a little more deeply a little later on. That's just for us to remember. So what are the different type of phenomena that we actually find? One is I was telling you about it. Okay. Second thing, you must have noticed that if you take a dish, okay, and maybe you are keeping a coin, a 5 rupee coin or something of that sort, and you're very slowly filling it up with water. And if you are looking at the coin from the edge, how will you find? Will you find that the coin is at the bottom, or does it appear to be raised up? Have you seen that? Or have you, no? It definitely appears to be raised up. You must have seen it in a bucket also. You know the bucket is quite deep, okay? Maybe if you have kept a stone or something of that sort. And when you're viewing it from outside, you will find that the stone has been raised up. The same phenomenon you'll find at a swimming pool. How many of you can swim? One of you can swim, yeah? Have you noticed it? If you're standing at the edge of the pool, the person who is in the pool will appear to be so short. Isn't it? Isn't it? So that's basically the phenomena of refraction. What has happened is the light is coming from one transparent media, which is maybe a swimming pool or a pond or something. When it comes into the air, the direction of the light changes. And that happens because the speed is not the same. Correct? So when it comes from one optical medium, now I'm talking about water and air. Okay? So this is what is known as a rarer medium. This is a rarer medium, and this obviously happens to be a denser medium. Now remember children, we are talking about dense, not in terms of mass density, but we are talking in terms of what is known as optical density. Okay, we say it is optically denser, and we say that is optically rarer. Did you understand all these words? Okay. So when I'm going to be talking, I'll say rarer to a denser medium or denser to a rarer medium, then obviously it means it is an optically denser medium. Okay. So just imagine that a person is running on land. So here we have this person who is running on land. Suddenly you will have sand there. Suppose he's running on the beach. Will he be able to run at the same speed? What happens to the speed? It decreases. Why? Obviously because the surface is different. Okay. What happens if he has to run in a pond which is filled with water? Will the speed be the same? No, once again. Why? Because medium has changed. Think on those lines. Okay. This is just a very crude example that I have given you. That the speed of a person who is running on different surfaces is going to be different. So the same way, I want you to imagine what is happening to light when it is passing from one surface to the other. Okay? What happens when light is passing from air into water? Okay? Did you understand? The speed of light will decrease. But when the light is coming from water, once again into air, what happens is the speed of light will increase. Are you okay with that? Okay, come on, take it. Take out your lesson. Write down part 2 so that you are comfortable that we are taking refraction. Now page number 145. Are you with me? Page 145. Light seems to travel along a straight line path in a transparent medium. Okay, what is the important word here? It has to be a transparent medium. Are you ready with your pencil so that you can underline? What happens when light enters from one transparent medium into another? Does it still move along a straight line path or change its direction? Okay, so obviously we know it changes its direction. You might have observed that the bottom of a tank or a pond containing water appears to be raised. Okay, like I told you here, it appears to be raised. Underline that statement and put a Q there. Why a Q? Because that can be a question. They'll ask you why does it appear to be raised and you have to answer. Similarly, when a thick glass slab is placed over some printed matter, the letters appear to be raised when viewed through the glass slab. Why does it happen? Put a Q. Okay, they've already asked you a question. Have you seen a pencil partly immersed in water? It appears to be displaced at the interface. That's a new word that you are learning. What is an interface? Interface of air and water. So this happens to be your interface. The boundary which is actually separating air and water, this is your interface. So where does refraction take place? Refraction is taking place at this interface. Is that okay? Yeah. And it's a boundary, yeah. It's a region of distinction between the two optical surfaces. Okay. Then, you might have observed that a lemon which is kept in water appears to be bigger than actually is. There are so many things like this which we have probably seen. Okay, day-to-day experiences. Today you are going to go home and observe what happens if you put lemon inside. Does it appear to be bigger or smaller? Okay, what happens if you put a stick inside, right? Then, how can you account for such experiences? So, they've given you plenty of examples here. Any of those examples can be asked for your question. Okay, come on, read. Let us consider second.
Let us consider the case of the apparent displacement of a pencil.
The word, underline, apparent displacement. Look at this word, apparent. Okay, what does it mean? It appears to be. Correct? It has not actually broken. It's not broken. The pencil is not broken, but it appears to be. That is why we call it as an apparent displacement. Then,
Partially immersed in water, the light reaching you from the portion of the pencil inside water seems to come from a different direction compared to the part above water. This makes the pencil appear to be displaced at the interface.
at the interface.
For similar reasons, the letters appear to be raised when seen through a glass slab placed over.
Okay. Have you tried with a transparent glass? Yeah, a glass of water, and you put it on the newspaper or on the book. Okay, the letters appear to be big. So basically, it is acting like a magnifying glass, isn't it? Okay. Continue. Does a pencil appear to be displaced to some extent? Yes.
Does a pencil appear to be displaced to the same extent if instead of water we use liquids like kerosene or turpentine?
Okay. Now, what could be? What is the question that they're asking? Here, right now, what have we taken? We have taken water. Okay. Instead of water, if I'm taking some other type of a transparent liquid like turpentine, okay, or if it is kerosene, will this nature of the pencil or the spoon getting displaced will be the same in all different in all liquids, or will it be different in different liquids? It obviously will be different, okay, because each one of them has got a different reactant that we study later. Yes, that is.
Will the letters appear to rise to the same height if we replaced a glass slab with a transparent plastic slab? You will find that the extent of the effect is different for different pair of media.
Okay, now listen to this word. I'm using a pair. What is this pair? I'm talking about water and air. Okay, so this is a pair of media. Did you understand that word? Those are the terms that you will be coming across. That's why I'm stressing right at the beginning. So, for example, for you are talking about air and glass. Did you find that this is a pair? This is a pair of media. So, when light comes from air to glass or glass to water, whatever it is, we are always talking with respect to a pair of media. Okay. These observations indicate that light does not travel in the same direction in all the media. Now, this is where your definition of your refraction, please mark it. It appears that when traveling obliquely, go on to the next page, obliquely from one medium to another, the direction of propagation. Did you understand? Direction of propagation of light in the second medium changes, and this phenomenon is called as the refraction of light. Okay, then you can also use the word the path of light changes or the direction of the path of light changes. Correct? From one medium to another. Okay. Now there are so many activities. Activities 9.7, 8, 9, etc. etc. Okay. We will first of all talk about refraction which is taking place through a glass slab, and then we will get back to the activity part of it. First of all, you will notice something regarding the direction of the path of light. Suppose I'm talking about a glass slab. Okay. So I say A, B, C, D is your glass slab. And I have a ray of light which is entering into the glass slab. So what is this? This is nothing but air. So did you notice what is the pair of medium? I'm taking air and glass. I'm having a ray of light coming from air to glass. That means it is coming from a rarer medium to a denser medium. Did you understand how it is coming? Okay. So obviously this light should have traveled in this line for which I'm just putting the dots. Will it travel in the same line? No. Okay. We find that it moves towards the normal. Now what is the normal? Normal is a line which is drawn at the interface at the point of incidence, right? Where do you find your angle of incidence? Is it between the normal and the incident ray, or is it between the glass slab and the incident ray? Everybody knows that, yes? So angle which is formed here between the normal and the incident ray, this is your angle of incidence. Okay. Now this angle, the ray will move towards the normal. So you find that the angle here R is much smaller as when compared to angle I. Is that okay? Take down this diagram because it's not given in your textbook. Once you have it, it becomes very easy for you to understand. First case. First case, draw this simple diagram. Ray of light is entering from a rarer medium to a denser medium. Air is the rarer medium and glass is the denser medium. Okay, so the ray of light is moving towards the normal.
Ma'am, it's the same diagram here.
Sorry?
This is the same diagram.
Yeah, but I'm talking about two different cases. I'm just breaking up this entire class lab experiment into two different cases and explain. So now here what happens to angle I and what happens to angle R? Which is more? This is more or this is more? Angle I is more. So angle I will always be more than angle R. Okay. Can you see from here?
Yes.
All of you can see. There is no glare on the board, right? Have you all taken it down? Okay. So did you understand why I is more and angle R is less? Obviously because the ray of light is not moving in the same direction, it is moving towards the north. Correct? Okay. Now let's take down another case. What happens when I have a glass slab, right? I've already drawn a normal and I'm talking about normal n and n dash, which is a normal. And let us say the light is coming from the glass slab outside. It is supposed to move in this direction along the dotted line. You think it will move in the dotted line? From where to where is it coming? It is coming from glass and it is coming outside to air. That means it is from a denser medium to a rarer medium. You will immediately realize that it is going to be opposite of what we have already seen. So will it move towards the normal? What will happen? It will move away from the normal. Did you see that? So this, instead of moving along the dotted line, is going to move away from the dotted line. So this is how it is going to be. So in this case, what is going to be here? This is angle R, which is your refraction, and here it is going to be angle of incidence. Is that okay? So what is going to be more here? Angle R is going to be more? Definitely, yes. So if it is moving from a denser medium to a rarer medium, that is from glass, if it is moving onto air, you will find that angle R is going to be more than angle I. Finish, right? Quick, quick. Don't waste your time. Rough diagrams, come on quickly. This is only for you to understand. And I'm talking about the third case. All these diagrams are not there, but if you have these diagrams, it becomes very clear when I talk about the glass slab. Learn easy, learn easy.
No, I have drawn it up.
When will you do it again? You will not have time. Please do. Do it now itself. As it is, you were doing it easy. Yes, fine. Okay. Can I start the third one? What happens when I'm taking a glass slab? Okay. This is the normal. Sorry, the normal is you see the normal? And I'm writing it as n and n dash. Is that okay? All of you please look at the board once. Okay. First case was like this. Can you all see my pen? Can you see this pen? So what is happening now? What happens to angle I? What am I doing? It is decreasing. Can you see that? Angle I is becoming 5 degrees, 4 degrees. Now what is it? 0 degrees. That means to say your incident ray is on the normal. So what is the angle of incidence? 0. In such a case, what will happen? There is no refraction. The ray passes along the normal. Do you understand? So when angle of incidence is 0, the incident ray is on the normal and there is no refraction taking place. The ray passes along the normal. Is that okay? That is why you will notice in the definition here. Look at the definition. The very first line. It appears that when traveling obliquely from, what is the meaning of the word oblique? Oblique means like this slant. Okay? So that has to be remembered when you do the definition. Here, oblique. Right? Not when it is normal. When it is normal, it just passes through and through. Same thing, even when it is coming from a denser to a rarer medium, if it is on the normal, it is just passing on the normal. Okay? Take up this. Last case, third case is the last case. Okay? When angle of incidence is equal to 0. Why I am mentioning all these things? A lot of MCQ will be asked here. What happens if it is 60? What happens if it is 0? Then R is equal to what? Then obviously there is no refraction taking place. Then the ray passes along the normal. Obviously angle R is also 0. Finish? Got it? Okay. Now, since we have understood the three rules, it becomes very easy for us to see the next thing, which is refraction through a glass slab. Okay, children, I think loss of refraction I have, but here I have the experiment which is based on a prism. Not this, I don't want this, I want something else. Not this, definitely. I'll show you the extent, okay? I'll get a glass slab and I'll show you how it is to be done. So come on. Now, in some of the schools, you will be probably taken to the lab and you will actually do this experiment. Can I just borrow your? You have a, somebody has a box like this, just to show you. Mata? This is it. So basically what we do in the lab, we'll ask to take a glass sheet like this, pin it up. Imagine that this is a glass slab. Samjha? Glass slab I'm putting here and I'm going to draw the outline. So if I draw the outline, how will it be? It is going to be like this. This is a very exaggerated big diagram I'm drawing just for you to understand. A, B and C and D. Okay. Then what am I going to do? I'm going to put two pins here. Pin number 1 and 2. And this pins that I'm putting is nothing but the incident ray. That means light is coming from here. See, it is oblique. If you see that it is oblique. And this is your normal. So at the point of incidence, I draw the normal and then n dash. So I put two pins here. Okay. That is your angle of, that is the incident ray. Now you will come from here and you are going to kneel down. Okay, and see like this. Can you see the pins in this space? If it is a glass slab, you should be able to see the glass slab. I am asking you to imagine, okay? So you will be able to see two more. Okay, so I'm going to put two more pins here. So when I put the two more pins here, it appears that it is not in a straight line. You understand? So what is happening here? Come on, take it up. So this is your incident ray. So I'm combining all these two diagrams. So diagram number 1 and diagram number 3, 1 and 2, I'm going to combine now and show you what happens in the glass line. So now it is coming from air, it is coming to glass. Correct? This is your incident ray and this is your angle of incidence. Okay. If there was no glass lamp, I'm going to put dotted line here just to show that it would have come out in a straight line. There's no bending. The dotted line is just a straight line. Okay. But now since the glass slab is there is a refraction taking place. Air to glass, what will happen? It will bend. It will bend towards or away? Towards. It is bending towards the normal. So now it is bending towards the normal. So this is our refracted ray. And this is our refracted angle of refraction, angle R. Correct? We have to put an arrow there to show that it is a ray. Will the ray come and stop here? Oh, I don't want to go out of the glass line. Obviously, it has to come out. Okay. So once again, at this point, there's going to be another refraction taking place. Here again, I'm going to draw another normal. This is your N and N. Okay, or M and N dash, whatever it is. So there is a second refraction taking place. The second refraction is what? From glass, it is coming out into air. Okay. Will it come in a straight line? Will it come in a straight line? No. Now it is coming from a denser region to a rarer medium. So will it move away or will it come towards? It will move away. Okay, so now it is going to move away. So instead of coming in the straight line here, it is moving away. That means to say what? It is coming from the glass slab, it is emerging out. So what type of a ray? We can call it as an emergent ray. And this will be your angle of emergence. Thanks, Peter. You understand the basics of the experiment? Now this entire thing we are explaining how we want to do that experiment. So we have actually seen how it has to be done. Okay?
Mom, we had a doubt.
Well,
The worksheet of 7.
that's just the image of what? Why are you looking at this one?
No, we had a doubt earlier.
Hold it on, hold on. We will finish this and I'll come. Are you okay, children? Did you understand this concept? Bending towards if the optical density is more, bending away if at all the optical density is less. Now what did we see? We'll see this angle I and this angle E is the same. Okay, so this is one of the laws. Angle I will be equal to angle E if you have done the correct measurements in the lab. Suppose I've taken an angle of how much is it? Maybe 40. This will also be 40. What do we find here? That there has been a lateral displacement. So instead of coming in a straight line, it has got displaced. So this is parallel to each other. Okay, that means the original incident ray and the emergent ray, but it has been displaced.
Is it always necessary to do that?
It will be parallel. It will definitely be parallel. Why? Because your I and E will be constant. And this displacement depends upon the thickness of the glass slab. Suppose this glass slab, okay, the glass slab that we have taken was a thin glass slab. So lateral displacement will be very small. Same thing if I have taken a thick one like this, then obviously the lateral displacement will be more. And it also depends upon the material. I've taken a glass, so it could be crown glass, it could be Pyrex glass, it can be an ordinary glass. depends upon the material that I have taken. Is that okay? Here? Okay. So what is the first thing that we have seen? Angle I is equal to angle E, and there is a lateral displacement. Take down this. So this is basically your lateral displacement. Okay. Then activity 9.10 of your textbook. Got it? They are showing you how it has to be done. 9.10. Next page, next page. Yeah. This glass slab here. Yeah, that one. Okay. In this activity, you will know blah blah blah. Right? That entire thing is like this. Look at the next paragraph in figure 9.10. Ray EO is obliquely incident. Underline the word oblique. That means in a slanting manner. Okay, on the surface AB called incident ray. O and O dash. So they have labeled it. Sometimes they are asking you a blank diagram like that, asking you to identify which ray is what. What is this ray? Incident ray. This is your refracted ray, and this is coming out. Therefore, it is the emergent ray. Right? Where is the refraction taking place? Only at one place or two places? Two places. One is taking place here, and the other one is here. So there are two places it's taking place. Okay. Come to the last paragraph. Now you're familiar with the refraction of light. Okay. Refraction is due to the change. Did you get that right? Last paragraph, 2-3 lines. It is due to the change in the speed of light as it enters from one transparent medium to another. Experiments show that the refraction of light occurs according to certain laws. So why does this bending take place? Because the speed of light is not going to be a constant. It is moving from one transparent medium to the other transparent medium, so obviously the speed is changing. Now just as we are having laws of reflection, again now we are going to talk about laws of refraction. By looking at the diagram, what can you understand? यहाँ का क्या law होगा? Look at the next page. Laws of refraction. Did you see the first one? Incident ray, the refracted ray, okay, and the normal to the interface of the two transparent media at the point of incident. They are all the same. So this is a plane. Got it? So they are all lying on the same plane at the point of incident. So use all those words at the point of interference. Okay, right. Now the second one is interesting. We are talking about the ratio of the sign of incidence, sin I by sin R. Here, this is your angle I, correct? And this is your angle R. In math, I think you have not yet started trigonometry, right? So if you take the value of sin I, for example, it is sin 40 or whatever it is, and there is a value, if you find that sin I to sin R, this is going to be a constant, and it is called as the refractive index. How will we write that? It is like an N, but with a long tail. This is your refractive index. What does it tell us? If you increase I, pay attention because such type of MCQs are going to be asked. Okay? If you are increasing angle I, angle R will also, it will increase, but it is always going to be less than I. Okay? Suppose I have taken a measurement for 40 degrees and R will be something less than that. Okay, maybe it is 35. I find out sin I and sin R, there is some particular number. If this is 60, this will also slightly increase, but the ratio of the sin I to sin R will always be a constant. And what is a constant called? It is known as the refractive index. So if you look at the table here, table 9.3, look at table 9.3 in your textbook. Material medium, air, ice, water, and refractive index they have given. There are two columns. Which has the maximum refractive index? Maximum. उसके नीचे देखो. Yeah, that is still continuing. Ground glass के बाद कौन सा है? Canada Bantam and rock salt, etc., etc. Then finally you find diamond. How much is for diamond? It is 2.42. Yeah, for diamond it is 2.42. Okay. This is the refractive index, right? And when we look at, let us say, water, how much is it for water? It is 1.33. Okay. So the greater the number here, the greater the refractive index, it means that the speed of light will be more or less. It will be less, because it will find it difficult to go into a light. In water, the refractive index is less, therefore the speed will be more. So what does it tell us about the velocity of light and the refractive index and the optical density? Okay, that is, it is inversely proportional. Okay, I'll come to that. Till here you have understood? Did you understand the second law? Once again, look at the second law. First law is over. We are now going to be talking about the second law. Put a tick mark for 1 and 2. Very important. Will be asked in all the exams. The ratio of the sine of angle of incident to the sine of angle of refraction is a constant for a light of a given color. Why we are talking about a given color? Because white light has got 7 different colors. Okay? For a given color and for a given pair of media. What does it mean for a given pair of media? Air and water or whatever it is. For all these values that they have given in the table, it is always with respect to air. Okay. Now, this law is also called as Snell's law. Underline. Why Snell? Snell was a Dutch scientist. He was an astrophysicist. Okay, and way back in 1670 or something, I don't remember the date exactly, he performed a number of experiments and he found out that this sign is important. Sign of the angle of incidence to sign of angle of refraction. That is always going to be a constant. Not if you are just writing I by R, it's not correct, children. Do you understand? This is not going to be correct. You have to write it as sign of. Only then it is going to be a constant. And what is this constant called? What is it called? It is the refractive index. Okay. Okay. Look at it. This is true for angle 90 more than angle I, which is going to be definitely more than 4. In this angle of incidence and R is the angle of refraction, then sin I by sin R is equal to a constant. Now for homework, please write down these two. Take down your home assignment. Leave some space and write it down. Don't type. No. All of you write it in your book. Can I just borrow your book for 1 minute? Okay. Write your question here. The only 2 things that you have to write. First law and the second law. So leave a couple of lines. You know your handwriting. Okay. A few lines you leave here and then you start. Otherwise you will forget. I want all the homework to be written in your notebook. Is that okay? Okay. I'll come back. And we'll continue. Let's see if I can put it. You should access today, right? You go wash your face.
No.
You're okay?
Yes. Today we had PE class.
Oh, okay. And you're into sports also, you said, huh? What do you
Play football.
and that will receive.
No, I played
And all of you must be very hydrated, huh? Especially if you're moving around, please make sure that you are very hydrated. You will sleep.
I